and welcome to this construction project management course. Every building you see around you, whether it's a home, hospital, bridge, highway, metro station, or commercial tower, start with one important thing, a strong project plan. But construction is not just about cement, steel, machine, and workers. It's about managing time, cost, quality, safety, people, material, risk, contracts, and client expectations all at the same time. That is why construction project management has become one of the most important skills in construction industry today. The construction industry is one of the largest industries in the world and it continues to grow rapidly. Reports also estimate that global construction work will grow from around $9.7 trillion in 2022 to nearly $13.9 trillion by 2037, with countries like India and US playing a major role in this growth. But with this growth comes a major challenge. Many construction projects face delays, budget overruns, safety issues, poor coordination, and last-minute changes. Studies have shown that a large number of major construction projects face cost overruns or delays, which clearly shows that good project management is not optional anymore. It is essential. And that is exactly why this course has been designed. Whether you're a beginner, a civil engineering student, a site engineer, a working professional, or someone who wants to grow into project management role, this course will help you understand how construction projects are planned, controlled, executed, and successfully delivered. We will begin with an introduction to construction project management. After that, we will move into construction planning, scheduling, and resource management, where you will learn how project timelines are managed. Next, we will cover construction cost estimation, budgeting, procurement, and contracts. This is one of the most important areas of construction management because every project depends on accurate cost, planning, proper budgeting, timely procurement, and strong contract understanding. We will also explore the tools and technology used in construction project management. Today, construction is becoming more digital and modern tools are helping project teams manage schedule, documents, cost, collaboration, reporting, and project tracking more efficiently. And then we will move into construction risk management and legal aspects. After that, we will cover construction execution, safety, quality, and change management. This is where actual site work happens. You will also understand how to coordinate daily execution, maintain quality standards, follow safety protocols, manage site teams, and handle changes without distributing the overall project progress. And finally, we will discuss construction closeout, handover, technology, and career readiness. By the end of this course, you will have a clear understanding of how construction projects move from planning to completion. But before we move on, let me share something exciting with you guys. If you are serious about building a strong career in project management, then PMP certification training in collaboration with Simplilearn can be a great next step for you. This course is designed to help you understand project management in practical, structured, and exam-focused way. You will learn important concepts like project planning, work breakdown structures, resource allocation, Gantt chart, risk and issue management, stakeholder communication, cost and budget planning, schedule management, agile and hybrid delivery, leadership, governance, and value-based project delivery. Now, what makes this course even more useful is that it also covers modern project management skills like Gen AI in project management, sustainability, business value, and real-world decision-making. So whether you are a project manager, team lead, software developer, project executive, engineer, or someone who wants to move into project management, this course can help you build the confidence, structure, and skills needed to manage projects better and grow in your career. So without any further ado, let's get started. Hello and welcome to Construction Project Management course. This course is designed to provide you with the essential knowledge and skills to successfully manage construction projects from start to finish. Whether you are new to the construction industry or looking to enhance your current understanding, this course will guide you through the critical phases of construction management, including planning, estimating, procurement, execution, quality control, and legal consideration. We will learn how to effectively manage cost, resources, timelines, safety, and communication, ensuring the successful delivery of the project. As we begin, it's important to understand that being a construction project manager goes far beyond just overseeing the construction process. A project manager is the key decision maker responsible for ensuring that the project is delivered on time, within budget, and to the highest quality standards. You will be the one who keeps everything on track, balancing client expectations, team coordination, and resource management. This role demands not only technical knowledge, but also strong leadership, communication, and problem-solving skills. Throughout this course, we will explore how a good construction project manager effectively manages all the moving parts building relationship with the stakeholder, solving problem, and keeping the project moving forward even when the challenges arise. Now, throughout this course, we will explore the following 7 modules. First is the Introduction to Construction Project Management, understanding the fundamentals and roles involved in managing construction projects. Then we have Construction Planning, Scheduling, Resource Management. Up next, we have construction cost estimation, budgeting, procurement, and contracts. Then we will see tools and technique involved in construction project management. Moving on, we will also see construction risk management and legal aspects, identifying and managing risk in construction projects, along with understanding key legal consideration. Then we will see construction execution, safety, quality, and change management. Then we will see construction closeout, handover, technology, and career readiness, closing out a project successfully, the role of technology, and preparing for career growth in construction management. In this first module, we are going to build the foundation for everything that follows. Now, before we talk about planning, scheduling, cost control, resource management, contracts, or execution, we first need to understand what construction project management actually means. This is important because if the basic picture is not clear in the beginning, then the advanced topic can feel confusing later. So in this module, we will start with the meaning of construction project management, that understand the difference between a construction manager and a project manager, then move into the different type of construction projects. After that, we will look at the phases of construction project lifecycle, then the key stakeholders involved. And finally, we will understand project delivery methods and contract basic. So this module is really about understanding the full picture we are going to discuss in detail. Let us begin with the most basic question. What is a construction project management? Now, in very simple word, construction project management is the process of planning, coordinating, and controlling a construction project from the beginning to an end. It means making sure that the project is completed on time, within budget, with the right quality, and in a safe manner. A construction project is never just about building walls, slabs, or structure. It is about organizing people, material, machinery, money, timelines, and decisions in the right way, so that the final result meets the client expectation. If this management does not happen properly, even a technically strong project can run into problems like delays, overspending, rework, poor communication, safety issues, or dispute. So construction project management acts like the system that keeps the entire project organized and moving in the right direction. Now, once we understand what is a construction project management, the next natural step is to understand who actually manages this work. This is where many beginners get confused between the role of a construction manager and the project manager. These two roles are connected, but they are not always exactly the same. A project manager usually looks at the bigger picture of the project. This includes the overall timeline, budget, scope, risk, coordination, reporting, and communication with stakeholders. The project manager is concerned with whether the project as a whole is moving in the right direction. The construction manager, on the other hand, is usually more focused on day-to-day execution happening at the site. This includes the site coordination, labor supervision, material availability, productivity, safety, subcontractor management, and actual construction progress. So in a very simple way, you can think of it like the project manager is responsible for the overall project success, while the construction manager is more focused on successful site execution. In some smaller projects, one person may handle both responsibilities, but in larger projects, these roles are often separate. Now, once the roles are clear, the next thing we should understand is that not all construction projects are same. The way a residential building is managed can be very different from the way an industrial plant or a highway project is managed. That is why it is important to understand the types of construction project. Broadly speaking, construction project can be divided into residential, commercial, industrial, and infrastructure projects. Residential project includes house, apartment, villas, and housing complexes. Commercial project include office building, malls, hotel, and retail spaces. Industrial project includes factories, warehouses, processing plants, and power facilities. Infrastructure projects include road, bridges, railways, airport, dams, etc. Now, each type of project has its own complexity, stakeholder, technical requirements, approval, timeline, and risk. Understanding the type of projects helps us understand how planning, management, and executing may differ from one project to another. So now that we understand what construction project management is, who manages it, what kind of project it applies to, the next logical question is this: how does a construction project actually move from idea to completion? Now this brings us to the construction project life cycle. The life cycle is a journey of the project from the moment it begins as an idea until it is completed and handed over. A simple way to understand this is through 5 processes: initiation, planning, execution, monitoring, and controlling closure. In this initiation phase, the project begins as a need or an idea. A client may decide that they need a new office, a residential tower, or a hospital or a bridge. Now, at this point, the project is still at a high level and basic feasibility is considered. In the planning phase, the project starts becoming more detailed. Scope, cost, estimate, schedules, design input, resource, permits, procurement plan, and risk consideration are developed. This is one of the most important phases because good planning creates a strong base for execution. The next phase is execution, where actual construction work begins on site. This includes mobilization, site preparation, procurement, coordination of contractors and subcontractors, and physical construction activities. Now, alongside execution comes the monitoring and controlling phase, where progress is checked continuously. The team reviews whether the project is on schedule, within budget, meeting quality standards, and following safety practices. Now, if any issue arises, corrective action is taken. Finally, in the closure phase, the project is completed, inspected, documented, and handed over. This includes final approval, snag correction, handover document, and closeout activities. When you understand the life cycle, you begin to see the construction project is not just a work happening on site, it is a full journey with multiple connected stages. Now, as soon as we understand the life cycle, another important idea naturally comes in. If a project moves through all of these phases, then who are the people involved in making all of this happen? That takes us to the concept of stakeholders. A stakeholder is any person, group, or organization that has interest in the project or can influence the project in some way. Now, in construction, there are always many stakeholders, and that is one of the reasons why communication and coordination are so crucial. The first major stakeholder is the owner or the client, because they are the ones who want the project to be completed and usually provide the funding. Then there is this project manager who helps coordinate the project at a broader level. There is also the construction manager, or we can say site management team, who focuses on day-to-day execution. Architects and designers are stakeholders because they prepare the design and technical vision of the project. Engineers and consultants such as structural, electrical, plumbing, or cost consultant also play an important role. Then there is this contractor who execute the work along with the subcontractor who perform specialized tasks. Suppliers and vendors provide materials, tools, and equipment. Regulatory bodies and government authority are also stakeholder because approval, inspection, and compliance often depend on them. In some projects, even the final user or the community become important stakeholder. So construction is never the work of one individual or one team. It is always a coordinated effort between many parties, and stakeholder understanding is essential for managing the project well. Now, once we know who is a stakeholder, the next question becomes, how are these parties connected formally in project? This leads us to project delivery methods and contract basics. A project delivery method is the way the owner, designer, and builder are organized to execute the projects. It defines how the responsibilities are shared and how the work moves from design to construction. One common method is design, bid, bid, where design is completed first, then contractors bid for the work, and then construction begins. This is a traditional and widely used method. Another method is design, build, where the one team handles both the design and construction. This can create faster coordination because design and construction are more integrated. A third method is construction manager at risk, where the construction manager is involved earlier, often during pre-construction, and help with planning, coordination, and cost control before full execution begins. These delivery methods matter because they affect timelines, communication, risk sharing, and control. Closely connected to delivery methods are contracts. A contract is a formal agreement that defines what each party is responsible for. It explains the scope of work, payment terms, time requirement, quality expectations, responsibilities, risk allocation, and procedure for changes or dispute. Now, in simple words, we can say the contract creates clarity. It tells everyone what they're supposed to do, what they will pay it for, and what standard they must meet, and what happens if something changes. Now, since construction projects involve large budget, strict timelines, and many parties, contracts are extremely important for keeping the project legally and operationally clear. So, if we now step back and connect everything together, we can see a full picture of this module. We started by understanding that construction project management is the process of organizing and controlling a construction project from start to finish. Then we looked at the difference between the project manager and a construction manager, so we could understand that the two major management roles. After that, we explored the different type of construction project, which helped us see that management can vary depending on whether the project is residential, commercial, industrial, or infrastructure based. From there, we moved into 5 phases of the construction project life cycle, which showed us how project moved from idea to planning, then execution, monitoring, and closure. Once that flow was clear, we looked at the key stakeholders involved at any stage of the project. And finally, we understood how these stakeholders are connected through project delivery methods and contract. So each topic in this module builds naturally on the previous one and helps understand the construction project as one connected system, not as isolated concept. That is why this module is so important, because it gives overall framework. Now, once this framework is clear, the next module becomes much more easier to understand, because you already know what a construction project is, who manages it, what stage it goes through, and who is involved. So that is all for this module. Let us move to the next module. Now, in this module, we are moving into something much more practical. We are going to talk about how a construction project is actually planned before and during execution. And honestly, this is one of the most important parts of the entire course, because even a very good project can fail if the planning is weak. In construction, work does not move properly just because people are present on site. It moves properly only when the work is clearly defined, arranged in the correct order, linked logically, supported by resource, and reviewed continuously. That is exactly why this module is important. Construction scheduling guidance commonly describe the schedule as the roadmap for sequencing work, assigning resources, and coordinating execution across the project timeline. In this module, we will understand how to define project scope, how to break work into smaller parts using WBS, and activity breakdown, how basic construction scheduling works, how activities depends on one another, what the critical path means, how labor, equipments, and materials are planned, and finally, how short-term or look-ahead planning helps the team stay realistic and ready on site. And don't worry, we are going to do all of this in a very simple and beginner-friendly way. The first thing we need to understand is scope. Now, before any schedule is made, before any bar chart is created, and before any resources are assigned, one basic question must be answered. What exactly is included in this project? That is the scope. Scope is the total work that the project is supposed to deliver. In very simple word, scope tells us what we are building, what work is included, and what the project team is responsible for completing. For example, if the project is a small apartment building, the scope may include site clearing, excavation, foundation, structure, machinery, plastering, electrical work, plumbing, flooring, painting, external development, and final handover. Now, this may sound obvious, but scope clarity is a very big deal in construction. If scope is not clear, then teams can misunderstand what work is required. Some tasks may be left out, some extra work may be done without approval, and time and cost can quickly go out of control. So the very first step in planning is always to define the scope properly. Now, once the scope is clear, the next step is to organize that scope into a structure that people can actually use. And this is where the work breakdown structure, or WBS, comes in. Now, the name may sound technical, but the idea is actually very simple. A WBS means taking the full project and breaking it down into smaller and smaller parts so the work becomes manageable. Instead of looking at the project at one giant piece, we divide it into major sections, then subsection, and then work package. Construction scheduling resources consistently place the WBS near the beginning of the schedule development, because it defines the project scope in manageable packages before activities, durations, and logics are added. Let us understand this with a very simple example. Imagine someone says we are constructing a commercial office building. That is still too broad for planning. So if we break it down into major parts like site preparation, foundation, superstructure, roofing, MEP work, finishes, and external work, then each of this get broken down further. Foundation may include excavation, PCC, reinforcement, form work, concrete, pouring, curing, and backfilling. MEP work may include conduit installation, piping, cable pulling, testing, and fixture. So that the WBS does it turn a large idea into smaller units of work that can be planned, estimated, scheduled, and tracked. This is very helpful because when work is broken down properly, the team can assign responsibilities more clearly, estimate cost more accurately, and monitor progress easily. Now, after the WBS comes the next level, which is activity breakdown. This is where we convert the work packages into actual activities that can be scheduled. For example, foundation work is still a broad package, but excavate footing pits, fix footing reinforcement, erect form work, and pouring footing concrete are activities. Activities are the real tasks that happen on site. This is important because schedules are not made from broad description. Schedules are made from clearly defined activity. So the flow is very natural. First describe the scope, then break into WBS and identify the detailed activities. Now that we have activities, the next question becomes, how do we decide when all of this work should happen? That takes us to construction scheduling basic. A construction schedule is basically a time-based plan for the project. It tells us what activities need to happen, when they should start, how long they should take, and when they should finish. In easy word, a schedule is a roadmap for execution. It does not tell the team what to do. It tells them when to do and in what order. This is why scheduling is such a core part of the project management. Without a schedule, site work becomes reactive. Teams may take decisions day by day that usually lead to delay, confusion, rework, ideal resources, and poor coordination. Now, when a schedule is developed, a few basic things are decided. First, the planner identifies the activity list. Second, an estimate duration is assigned to each activity. Third, the order of activity is determined. And fourth, these activities are placed across a timeline. Many beginner-level scheduling approaches use bar chart or Gantt chart because they are easy to understand visually. Activities are shown on one side and the time is shown across the top. So the team can quickly see what starts when, what finishes when, and how different activities overlap. Introductory scheduling material commonly teach bar charts and milestone chart as simple way to organize and communicate a construction schedule before moving into more advanced network logic. But here's something very important. Construction scheduling is not just about putting dates on tasks, it's about arranging work in correct sequence. In construction, work cannot happen randomly. There is a practical order to things. Now, you cannot cast a slab before fixed reinforcement and form work. You cannot paint wall before plastering is complete. You cannot install final fixture before the requirement rough-ins are done. So when we schedule, we are not simply creating a calendar, we are creating a logical execution plan. A dependency means once the activity depends on another activity. In simple word, one task cannot start until another task is completed. For example, excavation must be completed before foundation concrete can happen. Foundation work must be completed before columns can progress. Structural work must reach a certain stage before machinery or MEP installation can start. So dependency creates the logic of the project. They shows the relationship between two tasks. This is very powerful concept because once activities are linked by dependencies, the schedule becomes much more realistic. It reflects how work actually happens on site. Some activities happen strictly one after another. Another activity can happen in parallel. Now, for example, while curing is happening in one area, reinforcement work starts in another. Or while upper floor structure work is continuing, lower floor or block 4 work may already begin. So the project manager or planner must think carefully about what must happen in sequence. Now, once dependencies are in place, we can start understanding one of the most talked about concept in planning, and that is critical path. Now, this term sounds serious and honestly, it is important, but the idea is not difficult. The critical path is the longest chain of the dependent activities that determines the minimum time needed to finish the project. In other words, if any activity on critical path gets delays, the whole project completion gets delayed. Now let us understand this simply. Now imagine a project has 3 activities: excavation, foundation, column, slab, machinery and plastering. If these are all linked one after another, then they form a chain. Now if the slab activity is delayed by 3 days and slab is on critical path, then the entire project also gets delayed by 3 days unless corrective action is taken. So the critical path shows up which activity are time sensitive from the project completion point of view. This does not always mean those activities are the hardest technically. It simply means they are the activities that directly control the finish date. That is why project managers monitor critical path tasks very closely. If labor shortage, material delays, bad weather, or design changes affect a critical path activity, then that issue becomes very serious. So if you want to remember this concept in an easy way, just remember this line. The critical path is the chain of activities that cannot slip without delaying the project. Now, once the schedule and sequence are understood, the next question automatically comes is, even if we know what should happen and when it should happen, do we actually have the resources needed to do it? That takes us into resource management, and this is where planning becomes even more practical. In construction, the 3 major resources we usually talk about is labor, equipment, and material. Construction scheduling guides also connect scheduling directly with resource allocation because the schedule only becomes executable when labor, equipment, and materials are assigned properly to the planned activities. Now let us start with labor planning. Labor planning means deciding what type of workers are needed, how many are needed, and when they are needed. For example, excavation may require machine operator and helpers. Reinforcement work needs bartenders and fitters. Farm work may need carpenters. Machinery needs mansions and helper. Painting needs painter. Now, if labor is not planned properly, 2 problems can happen. 1, too few workers are available. Second, too many workers are brought in too early and they remain idle or unutilized, which increases cost and reduce productivity. So good labor planning means matching labor deployment with the schedule. Next comes equipment planning. Construction work depends heavily on machinery and equipment such as excavators, cranes, compactors, mixer, pumps, truck, vibrators, and generators. These resources are expensive and in many cases they are hired for specific period. So equipment planning is all about deciding what equipment is required, when it will be needed, and for how long, and whether site conditions are ready before it is mobilized. Now, for example, bringing a concrete pump to a site before formwork and reinforcement are ready create waste. Bringing a crane before lift plans are clear can create insufficiency. So equipment planning is not just about having machines, it's about using them at the right time. Then comes material planning, and honestly this is a huge part of real site management. A project can have a perfectly good schedule, but if materials do not arrive on time, work can stop immediately. Material planning includes deciding what materials are needed, in what quantity, when they are needed, and how they will be procured. For example, concrete, steel, brick, blocks, tiles, pipes, cable, fixtures, door, glass, and paint all need to be planned in advance. Some materials have also lead time, some require approval before ordering, some need special storage conditions, some are bulky and create congestion if delivered too early. Now this takes us to one of the most practical and useful ideas in real project execution, and that is short-term planning, also called as look-ahead planning. See, a master schedule may cover the full project for months or even years. It is important, of course, because it gives the overall project roadmap. But site teams cannot work effectively by looking only at long-term schedule. They need some short-term view of what is coming next. That is where look-ahead planning comes in. A look-ahead plan is a near-term planning view that focuses on upcoming work, usually in a 2-week, 3-week, or 6-week window, depending on the project and team. Now, recent construction planning guidance describe it as short-term, zoomed-in fragment of the master schedule used to prepare crews, check readiness, and manage constraints before the work begins. The purpose is very simple: to make sure that the work planned for the near future is actually ready to be executed. So instead of only asking what does the master schedule say, the team asks what are we supposed to do over the next few weeks and are we truly ready to do it? Now let me take you to a simple example. Suppose slab casting is scheduled for next week. In a look-ahead planning meeting, the team will review whether the Shuttering is complete, whether reinforcement is tied, whether the drawing are approved, whether the concrete supplier is confirmed. Now, if any of these things are still not ready, then the team knows there is a constraint and that issue can be addressed before the actual work arrives. And this is why look-ahead planning is so valuable. Now, many project delays do not happen because the master schedule was wrong. They happened because the upcoming work was not made ready. Materials were late, approvals were pending, another trade had not completed its work. Labor was unavailable, access was blocked, so look-ahead planning acts as a bridge between the big schedule and the real site condition. It turns long-term intent into short-term action. Now, this was all for this module. Let us move to the next module. We now understood how construction work is planned, scheduled, and supported within the resources. Now, in this module, we are moving into another very important parts of construction project management, and that is money, buying, and formal agreements. In simple words, we are going to understand how a project team estimates cost, builds a budget, buys material and services, selects vendors, and manages contract and payment. And honestly, this is a very important module because even if the engineering is strong and the schedule looks perfect, a project can still struggle badly if cost planning, procurement, and contract control are weak. Construction references consistently treat estimating, budgeting, procurement, and contract as closely connected control because cost decisions affect what gets bought and when it gets bought and how work is paid for. Now let us begin with a very basic but very important distinction: estimating versus budgeting. These two words are often used together and beginners sometimes think they mean the same thing, but they are not exactly the same. Now, if we talk about estimating is the process of forecasting what the budget is likely to cost. Budgeting is the process of taking those estimated costs and turning them into an approved financial plan for the project. So, estimation comes first and budgeting comes after that. Now, for an example, if the team studies drawing, quantities, labor rates, equipment needs, and material prices and arrive at an expected project cost, that is an estimation. But when the management decide how much money will be actually allocated to different parts of the project and sets spending limit, that becomes budgeting. Industry guidance describe estimating as a forecasting project cost and budgeting as in using those figures to manage spending and financial limits. Now, once the difference is clear, the next thing we should be focusing is understanding what actually makes up the cost of a construction project. Broadly, costs are often grouped into direct cost and indirect cost. Direct costs are the costs that can be directly linked to a specific piece of project work. These usually include labor, material, equipment used for the job, and sometimes subcontracted work tied to defined activity. So if concrete, steel, shuttering labor is used for a particular part of project, those are direct costs. Indirect costs are different. These are the costs that support the project but are not tied to one single physical work item. These can include site office expenses, supervision, temporary utilities, insurance, permits, safety arrangement, communication system, and general site administration. Now, construction guidance commonly explain indirect costs as a necessary project support expense that still must be planned, budgeted, and reviewed regularly. This distinction is important because if a project manager only looks at obvious direct cost and ignore the indirect cost, the financial picture becomes incomplete. A project may look profitable on paper, but once supervision, temporary work, compliance cost, and site overhead are added, the real cost position may look very different. So, a good construction financial planning always looks at the both direct and indirect costs together. Now, you can remember it like this: direct costs build the company physically, while indirect costs help the project function and run smoothly. Now, once a budget is prepared, the job is not over yet. In fact, that is where another major responsibility begins, and that is cost tracking and cost control. A budget is useful only if team keeps comparing planned costs with actual costs during the project. Cost tracking means regularly recording what has been spent, what has been committed, and what is still expected to be spent. Cost control means analyzing that information and taking action when the project is drifting from the approved budget. Now, taking an example, if steel consumption is higher than expected, labor productivity is lower than planned, or higher equipment is staying on site longer than necessary. Those issues affect cost and must be controlled early. Now, modern construction budget guidance emphasizes that a project needs ongoing tracking, review, and correction action rather than just a one-time budget document. And honestly, this is where many real projects struggle. The problem is not always that the original estimate was bad. Sometimes the estimate may have been quite reasonable, but the actual spending is not tracked closely. Changes are not recorded properly, and site team continue spending without realizing how far they are moving away from the plan. So cost control is really about visibility and discipline. The team must know what was planned, what has actually happened, and why the differences exist. Only then can decisions be taken in time. Now let us move to the next big topic, which is procurement planning. Now, procurement in simple words meaning obtaining the material, equipment, and external services needed for a project. In construction, a lot of work depends on outside supplier and subcontractors. So procurement is not a side activity, it is a central part of the project delivery. Procurement planning means deciding what needs to be bought, when it needs to be bought, how it will be bought, and who will approve it, and how deliveries will be coordinated with the schedule. Now, construction procurement guidance commonly start with defining the scope, preparing quantity takeoffs, then creating the budget and a procurement plan that sets timeline, contract approach, and vendor selection criteria. Now, this is very important because materials and services do not appear on site automatically. Let us say a project needs structural steel, glazing, HVAC equipment, or elevators. Now, some of these items may have long lead times. Some of them need shop drawing approvals before ordering. Some may come from specialized vendors. So if procurement planning starts late, then schedule can suffer even if the execution team is otherwise ready. That is why good project manager coordinate procurement with construction sequencing. They ask questions like what must be procured first, what requires long time lead, what can be bought locally, or what needs technical approval, and what risk could be associated. Now, once procurement planning is done, the next step is often preparing tender packages and moving towards vendor selection. Now, a tender package is a set of document issues to potential vendors or contractor so that they can understand the work and submit a bid or a quotation. Now, a strong tender package usually gives enough clarity for bidders to price the work properly. It may include drawings, specifications, scope of work, quantities, commercial terms, timeline, instructions, and condition of the contract. Industry tender management platform describe this stage as structured distribution of bid or tender document alongside with the agenda clarification and controlled communication. Now, once this bid comes in, the team does not simply choose the cheapest option without thinking. Good vendor selection looks at more than the price. It also considers technical capabilities, past experience, quality standards, financial stability, delivery reliability, safety records, and ability to meet schedule requirement. In some cases, a cheaper vendor may create bigger delays or quality issues later, which usually makes the project more expensive. So vendor selection is really about choosing the most suitable and dependable option, not just the lowest number on the paper. Now let us move into contract basic, because once a vendor or a contract is selected, the relationship must be formalized properly. Now, a contract is the formal agreement that defines what work must be done and how much will be paid, what timeline is, what standard must be met, and how risk, changes, and disputes will be handled. Now, in simple words, the contract creates clarity. It tells each party what is expected from them and what happens if something changes. Now, procurement guidance also ties contract planning directly to vendor selection and payment management because contract terms control how work is administered after award. Now, one very important contract concept in construction is variation, sometimes also called a change order depending on the contract system. A variation happens when the original scope, quantity, specification, or method of work changes after the contract is in place. For example, the client may request an additional wall, a design may change, material specification may be upgraded, or unforeseen site condition may require extra work. These changes can affect both time and cost. That is why variation must be handled carefully, documented clearly, priced properly, and approved through the correct process. If variation control is weak, then dispute, payments, delays, and budget overruns become much more likely. And this leads us to the final topic of this module, which is payment control. In construction, payment control means making sure that payments are linked to actual work done, contractual terms, approved rates, and proper documentation. Payments are not just random money releases, they are a part of project control. Many construction systems use tools like bills, running account invoices, or a schedule of values to connect completed work with payable amount. Construction payment guidance describes progress payment tracking as a structured process tied to contract terms and progress records. Now, this matters a lot because poor payment control creates stress for everyone. If contractors are paid late without a reason, progress can slow down. If they are overpaid too early, the owner loses control. If quantities are not verified properly, billing disputes begin. So a good project manager checks what work is complete, what is approved, what variations are pending, what retention or deduction apply, and whether the payment being released is contractually correct. So if we bring this whole module together, the flow is actually very simple. First, the team estimate what the project is likely to cost. Then those estimates are converted into budget. After that, direct and indirect costs are understood. So the financial picture is realistic. During execution, costs are tracked and controlled so the project does not drift away from the plan. At the same time, procurement planning ensures that the right material, equipment, and external services are brought at the right time. So this was all for this module. See you in the next one. Welcome to this module on technology integration in construction. Now, as we have discussed so far, construction management involves a lot of moving parts, managing cost, scheduling teams, and ensuring everything goes according to plan. But here's the thing, over the past few years, construction has changed a lot, especially when it comes to how we use technology on projects. We're just not talking about using computers and smartphones to manage the job anymore. Technology is now integrated into every step of the construction process, from the planning phase to the way we track progress. And even how we ensure quality, technology is improving how we work. And in this module, we are going to take a closer look at the tools and systems that are helping make construction projects more organized, efficient, and reliable. Now let us start with something that's really making a difference in the industry today, Building Information Modeling or BIM. Now what is a BIM and why does it even matter? Now you have probably heard of BIM before, but what exactly is it? To put it simply, BIM is a digital way of representing a building or infrastructure project. But it's more than just a 3D model you look at on a computer screen. It's a complete digital version of the building that includes every detail you might need to know. Now imagine you're working on a new office building. With BIM, you don't just get to see what the building looks like. You also get real-time information about things like material, plumbing, electrical system, and even how the air conditioning work. Everything is right there in the digital model. And it's not just for the design team. Everyone working on the project can access it. Now this is a huge because it helps everyone stay on the same page. Now for an example, if the electrical team sees a potential issue with the way the plumbing is laid out, they can catch it before any work is done. BIM is a layout preventing problems before they happen. By providing a single source of truth for everyone involved in the project, BIM helps avoid mistakes that could slow down the progress or cost more to fix later. And it's not just about the layout design. As the project moves into construction, BIM continues to be useful. You can track the progress of the building in real time, see which part of the project are finished, and ensure everything is being built according to the plan. It's like a live document that helps you manage the entire project. Now coming to the second pointer, which is how technology is changing the construction site. So that now we understand BIM and how it's used, let us talk about how technology is being used on site. The part of construction is where technology really starts to make an impact. Let us start with the drones. You might think of drone as something used to take photos or videos, but in construction, they are used for surveying and site monitoring. Instead of walking around the job site manually, checking progress, drone can fly over the sites and provide real-time aerial images. This means that the project manager can instantly see the entire site from above and check on how things are going. Now, it doesn't stop there. Drones are also useful for measuring the progress of the project, tracking stockpiles of the material, and even checking safety compliances. Now, imagine being able to see a detailed high-resolution map of the construction site without ever stepping foot on the ground. That's the power of drone. They help save time, reduce error, and improve safety by allowing you to monitor things from a distance. Now, next up is IoT, or the Internet of Things. You may have heard the term, but let's break it down. Now, basically, IoT involves connecting everyday items to the internet to share data. In construction, this can mean things like sensors placed on the equipment to track its uses, temperature, and condition. For example, smart sensors on a crane might monitor its load and alert the operator if it is being used beyond its capacity. This can help prevent breakdown or overloading, ensuring that equipment is used safely and efficiently. Now, this use of IoT also extends to monitoring environmental condition. If you're working on a construction site during the winter, you can use sensor to track things like temperature and humidity in real time, so that workers aren't exposed to hazardous condition. Now, in short, IoT make construction safer and more efficient. Now, another exciting on-site technology is augmented reality, which is known as AR. AR lets worker overlay digital images onto the physical world. For example, with AR glasses or tables, a worker can see the construction plan overlaid into physical structure as they are working. It's as if the plan are right in front of them, helping them see exactly where things need to go without having a constantly reference paper blueprint. Now let us talk about how technology makes life easier for a project manager. Now, managing a construction project isn't just about coordinating teams and staying on the top of the budget. It is also about managing timelines, resources, and documentation. And that's where tools like Primavera, MS Project, and Procure comes in. Now, Primavera is a software tool that often used for large complex projects. If you have got a project with many tasks, lot of subcontractors, and a tight schedule, Primavera helps you create detailed project schedule, track critical path, and ensure resources are allocated efficiently like it's having your own project. Then there is this MS Project. This tool is a little simpler and more accessible than Primavera, but it is also incredibly effective for smaller to medium-sized projects. It helps you create timelines, track tasks, and monitor progress. MS Project is perfect for keeping things organized and ensuring that everyone knows what they need to do, when, and how. Now, Procore is another tool that's widely used for managing construction projects. It's a cloud-based platform that brings everything together, from document controls to RFIs to submittals. Procore helps keep track of all the important paperwork and keeps everyone involved in the project. Whether it's updating the schedule, checking the budget, or managing communication with subcontracts, Procore helps you do it all at one place. These tools make construction management much more organized and efficient. They provide real-time data which helps you make decisions quickly, and they give you the overview of the entire project. So if there is any issue with the task or the delay, you will know about it immediately and you can respond without wasting any time. Okay, so now that we have covered the basic of how technology is currently being used in construction, let us take a quick look at what the future holds. The construction industry is evolving rapidly, and technology is only going to play a bigger role moving forward. Now, one of the exciting technologies on the horizon is digital twins. A digital twin is essentially a virtual model of the building that can be updated in real time. It's connected to actual building, so if something changes like a system breakdown or a design modification, it is reflected in the digital twin. The technology allows the building owner to track performance, monitor system, and plan maintenance all in one place. Then there's the growing use of robotics in construction. Robots are already being used for tasks like bricklaying and material handling, but in future we might even see more advanced robots that can help with construction site inspection or demolition. While robots won't replace the workers entirely, They will make certain tasks faster, easier, and more precise. So there you have it. Construction is being transformed by technology, and the chances we are seeing today will only continue to grow. So this was all for this module. Thank you, and we'll see you in the next module. Hello and welcome back. In this module, we are going to dive into something that is absolutely critical in construction, but it is often overlooked by beginners: risk management and legal aspect. Now, when we think about construction, we often imagine the hard work on the site, the tools, the material, and the teams working together to build something amazing. But the thing is, no matter how well planned a project is, things can still go wrong, and sometimes they will. Unexpected risk, whether it is bad weather, a sudden accident, or a supply chain issue, are all a part of every project. And that's where risk management comes in. It's all about identifying, assessing, and preparing for those risks before they happen. But it's not just about risk on site. There are also legal aspects that we need to be prepared of. Construction involvement contracts, regulation, and legal responsibilities that must be handled properly. If you don't understand the legal side of things, you could find yourself in some serious trouble, whether it's dealing with safety, violation, or navigating contractual disputes. In this module, we will take a close look at how to identify risk, how to manage them, and why understanding construction law is so important. So let us jump in. Let us start by talking about risk. Now, in construction, risk is just about anything that could interfere with your project going as planned. Some risks are obvious, like the chances of construction worker getting injured on the job, but others are less visible, such as risk of project delay because supplier can't deliver materials on time, or the risk of the budget overruns due to unforeseen costs. Now, let me put it this way. Now, imagine you're working on high-rise building project, and halfway through the project, there is a major storm that damages a large part of your building site. That's an example of an external risk, something completely out of your control, but still something you need to prepare for. Or maybe during the middle of your project, you find out that your supplier's factory is facing a labor strike and suddenly your building material aren't available. This would be a supply chain risk, and it could delay the entire project. Now, risk doesn't always mean something bad is going to happen. Sometimes it could mean a chance to improve. For example, if you identify that a certain piece of equipment has the potential to break down, you can replace it before it causes any delay. That is exactly what risk management is all about: identifying the potential issues before it happens so you can take steps to avoid it. Now, talking about the types of risk in the construction, there are different types of risk you will encounter on any project, and it is helpful to break them down into categories so you know where to focus your attention. Now, here's a quick rundown of some of the types of common risk you might face. First is safety risk. Safety is the biggest concern in construction. You have probably heard of fatal fall, struck by incident, and electrical hazard, and getting caught in between, which are leading causes of the injury and death on construction site. Preventing accident is a major part of managing safety risk. So how do we manage safety risk? It starts with having a solid safety plan. That's training worker, ensuring the right protective gear is being used, and making sure safety measures are followed all the time. Now, there is environmental risk. These are the risks related to things like weather condition, soil quality, or environmental regulation. For example, heavy rain or extreme temperature can delay work, and poor soil condition can impact the foundation of a building. These environmental factors need to be considered during the planning phase, and contingency plan should be placed just in case. Then there is financial risk. Managing the project budget is another major concern. Financial risks include cost overrun, inflation of material prices, or unexpected expenses. When managing finances, it is important to regularly track the budget and manage adjustment whenever it is necessary. Sometimes there may be risk related to cash flow. For instance, if clients delay payment, it could impact your ability to continue funding the project. Then there is legal risk. Construction projects are heavily regulated by law, so there are always legal risks. These could include issues with contracts, permits, and compliance with the local zoning or safety law. If you're not familiar with the legal requirement in your area, this can lead to dispute, fines, or even a shutdown of the project. Then there is the schedule risk. Sometimes delays are inevitable. Schedule risk can arise from things like unexpected weather, late deliveries, or labor shortage. The key is having a flexible timeline and knowing how to adjust when issues arise. One thing you can do is build buffer time into your schedule to account for possible delays. Now let us talk about risk assessment. Once you have identified the potential risk, you need to assess how likely they are like to happen and how much impact they would have on project if they do occur. This is where you get to think about how you can mitigate these risks. For example, let's say you have identified a risk of material delays because of supply chain issues. You can mitigate this by having a list of backup suppliers and by placing orders early. Or maybe you have recognized a safety risk related to the use of a certain tool. You can mitigate this by providing extra training or by replacing the tools with a safer alternative. Now, in construction, we usually use a risk matrix to help evaluate risk based on two factors. First is likelihood, and second is impact. If it happened, how big of a problem will it cause? You can use the matrix to prioritize which risk to focus on first. For example, a high impact risk like a worker injury is obviously something you will want to mitigate immediately, whereas a low impact risk like a slight delay in a non-critical task can be managed with less urgency. So now that we have discussed managing risk, let us talk about the legal side of the construction projects. This is a really important area because as a project manager, you need to be aware of various legal responsibilities you have. First off, there is a contract law. Contracts are the foundation of any construction project. You need to make sure that contract clearly defines expectations, responsibilities, and payment terms. For example, if a subcontractor fails to complete work on time, the contract will outline what happened next, whether there are penalties or how they can get paid for work completed on schedule. Now, it is also important to know about permitting and zoning law. Before you start any construction, you must ensure that you have all the necessary permits and that your project complies with local zoning regulation. If you fail to get proper permits, it could lead to fines or even a work stoppage. Now, another area of construction law is worker safety. There are strict regulations around how construction sites need to be managed in order to protect workers. This includes things like having safety barriers, ensuring PPE, personal protective equipment is used in following OSHA guideline to keep everyone on site safe. If there's any accident and it is found that safety protocols were ignored, you could face legal trouble, including lawsuit. Now, disputes can sometimes arise during construction projects, whether it's over contract term, deadlines, or work quality. As a project manager, you need to be prepared to handle these disputes quickly and fairly. This is where dispute resolution comes into play. Now, construction disputes are typically resolved through negotiation. Sometimes issues can be worked out simply by talking it over with the parties involved. Or mediation. If negotiation doesn't work, a neutral or a third party can help both sides come to an agreement. Then there is arbitration. If mediation fails, arbitration involves a neutral third party making a binding decision to resolve the dispute. And then we have litigation. If all of these else fail, you might end up in court. But this should also be a last resort as it is costly and time consuming. Now, knowing how to navigate these processes, keep everything professional and is key to managing construction projects smoothly. So there we have it. Risk management and legal aspects are two areas that can't be overlooked in construction. Being proactive about identifying and managing risk will help ensure that your projects stay on track. So this was all for this module. See you in the next one. Hello again and welcome to the final module of this course. I'm really excited to dive you into today's topic because as you will see, closeout and handover is an incredibly crucial stage in the construction process. Sure, we have already discussed the basics, how projects are planned, the importance of cost management, how safety and quality are handled, and the many complexity that come with the managing communication and execution on site. But here's the thing, a construction project is never truly complete just because the physical work is done. In fact, the real success of a project comes at the end when all the work is properly documented, tested, and transferred to the owner. So in this module, we will talk about what happens when the project is almost finished, what testing and commissioning entail, and why handover documentation is just as important as building itself. Plus, we will take a look at how digital tools like BIM and platforms such as Primavera, which we already discussed in the previous module, works. Finally, I will walk you through some essential skills that every aspiring construction manager needs to grow and succeed in this dynamic field. Now let us think about this for a second. When most beginners hear that a project is finished, they might think, well, the building is up, so everything must be done, right? Well, that's actually just the beginning of the real completion process. When we talk about the end of a project, it's not just about seeing the physical structure standing tall. Sure, the walls are up, the floors are installed, and the roof is on. But before the project can be officially handed over to the owner, there are some critical checks and tests that needs to be done. This is where testing and commissioning comes in. Testing involves checking individual system, equipment, and installation to ensure that they function correctly. For example, is the plumbing system working properly? Does the fire alarm system activate as it should? Is the HVAC system cooling and heating the space effectively? These systems need to be checked for quality and reliability. If something is off, now is the time to fix it. But that is not all. Commissioning takes things one step further. It's the process where we ensure that all the system, equipment, and installation work as part of an integrated whole. You see, a building isn't just a bunch of isolated systems, it's an interconnected structure where everything must work in harmony. Commissioning ensures that, for example, HVAC system doesn't just work in isolation but integrates smoothly with the building's temperature and control system. Air quality and energy efficiency plans. It's about making sure everything comes together and work as a unified system. It's much more than one last test. It's about making a system ready for actual use by the owner. For an example, let us say a high-rise office building is nearing completion. The elevators need to be tested for their speed, capacity, and reliability. The fire alarm and emergency lighting needs to be tested to ensure that they will work in crisis. The elevated water tanks must be checked to ensure proper pressure. And the final part of this process isn't just a quick test, it's a thorough quality check that includes a review of system integration. Now, once we complete all the testing and commissioning phase, we move towards closeout. Closeout isn't just about filing paperwork, it's a critical part of the project where we tie up all the loose ends, finalizing punch list items, resolving final change orders, organizing records, closing out commercial issues, and preparing everything for the official handover. Now, if the closeout process isn't managed properly, it can cause delays, disputes, and frustration, especially when it comes time for the owner to take overall facility. Now, here's a tip. Don't leave closeout until the last minute. You want to make sure that during the entire project, you're collecting and organizing all the necessary documentation and information. This makes the end phase much easier and ensures you don't run into chaos when it's time to hand over the building. Now, closeout might sound like an administrative task, but in reality, it's one of the most important phases of the project. Now, handover documentation. Okay, so we have done testing and commissioning. Now, how do we wrap up everything? The answer lies in handover documentation. Now, let me put it this way. The owner is not just getting a building, they are receiving an asset that must be operated, maintained, and managed long after the construction work have left. The handover package ensures that the owner knows how to manage, repair, and maintain the system within the building. This handover documentation typically includes a detailed set of records, manuals, and reports. So, what exactly does this package include? Well, let us break it down. First is approved drawing and as-built drawing. These are the blueprints of the building. The as-built drawings show the final design that was actually constructed, including any changes made during the project. Operation and maintenance manual. These are the manual for all the system in the building. For example, the HVAC system manual will explain how to use, maintain, and repair it, ensuring that the owner's team know exactly how to keep the system running smoothly. Then warranties and product data. All the product used in the construction, whether it is windows, electrical system, or elevators, come with warranty. These documents ensure that if something breaks down, the owner can get it fixed or replaced without additional cost. And then inspection report. These reports show that the building was built to code that has passed all the necessary inspection, including structural integrity and safety. Then training record. The project team may need to provide training to the building's maintenance crew to show them how to operate the various systems within the building. Now, if these documents are missing or incomplete, the owner will face major difficulties managing the building later on. And for the contractor, not having organized handover documentation can lead to payment delays and dispute. So the lesson here is very simple. Handover is about completing the project both physically and administratively. Now that we have covered the completion phase, let us talk about something that is changing how we do everything, which is BIM and digital tool, which we already discussed in the previous module. But let us discuss this in detail. The construction industry is rapidly evolving and the BIM at the forefront of the change. But what exactly is BIM? Now, at its core, BIM is a 3D model-based process that allows architect, engineer, and construction professional to plan, design, construct, and manage building more efficiently. But BIM is not just a pretty 3D model, it's a model that contains a wealth of data and information like materials, schedule, cost, installation methods, and even maintenance schedule. Now imagine being able to visualize not just how the building looks, but also how the HVAC system interacts with the electrical system, or how changes to one part of the building might affect another. This kind of coordination is possible with BIM, and it can be a game changer. For example, if there's a potential clash between two systems like an air duct crossing through the beam, BIM helps team identify and resolve these issues before the construction begins. But BIM isn't just useful during construction. Once the project is complete, the BIM model can serve as an important tool for the building's operation and maintenance. Now to wrap it up, let us see the key skills for a construction project manager. Let us talk about the most important part of a construction manager, the skills you need to succeed. Now by this point, you have learned about the entire construction process from planning to execution to closeout. But what makes a good project manager isn't just a technical knowledge. It's about knowing how to coordinate team, manage resources, and navigate the challenges that rise on site. So what skill you should be focusing on? First off, you will need a solid understanding of the project scheduling and budget management. You will need to be comfortable with tools like Primavera or MS Project, but you also need excellent communication skills to manage stakeholders and keep teams informed. And let's not forget about problem solving. Things don't always go as planned, so you need to be able to adapt quickly. Well, there we have it. We have covered everything from testing and commissioning to handover, documentation to BIM and digital tools. The role of construction project manager is challenging, but it is also incredibly rewarding. You are the one responsible for bringing it all together from start to finish and making sure everything is completed to the highest standard. So whether you are managing schedule, budget, or team dynamics, you are the glue that holds everything together. Thank you so much for sticking with us till the end. I hope you feel more confident in understanding the full scope of a construction project and the skills you need to excel as a project manager. The construction industry is always evolving, and with that digital tool and new technique, it's an exciting time to be the part of this field. Keep learning, stay curious, and more importantly, stay organized. Good luck on your journey.